So now that we know what the quadratic function is, what it looks like, that it's called a parabola, and how to determine whether it's concave up or down, we're going to take a look at how to determine a really important point called the vertex, which can either be a maximum point or a minimum point. So let's take a look. So now let's talk about the maximums and minimums of quadratic functions and their graphs, okay? And it's very closely related to concavity, which is why we're going to talk about this next. So again, if we're given a quadratic function in the form, that general form that we keep talking about, f of x equals ax squared plus bx plus c, well, we know that if a, that coefficient a right here, right, we know that if it's positive, if it's greater than 0, meaning if it's positive, the parabola is concave up, okay? We know that. We just talked about that on the last slide, okay? But that also means that that parabola has a minimum point. And what is it? I'll show you. There it is. That's the minimum point. And that should make sense, you guys, right? Because minimum, you think smallest, right? It's down here on the bottom of the graph, okay? Minimum point. Well, conversely, if A is negative, right? Again, we just talked about. So if A is less than 0, meaning it's negative, this A term right here, if it's negative, well, that means the parabola is concave down, which we just talked about, shaped like the A, and it has a maximum. And what is the maximum? It's that top point. All right, so if we have a parabola that's concave up, we're going to be dealing with a minimum, okay, of a bottom point. If we have a parabola that's concave down, we're going to be dealing with a maximum, a top point. And that should sort of make sense in your mind, right? You think maximum, you think biggest, you think minimum, you think smallest, okay? So concavity is also going to tell us whether or not we're dealing with a parabola that's got a minimum or a maximum. Well, as it turns out, those maximum and minimum points, they have a special name. They're called the vertex of the graph. A vertex can either be a maximum or a minimum, okay? If our graph is concave up, the vertex will be a minimum. If our graph is concave down, the vertex will be a maximum. So I want to take a look at one of the graphs that we saw on the last page. It was the graph where we had a minimum, right? Our parabola was concave up. Okay, so we were dealing with a minimum point. That means that we are dealing with a vertex that is a minimum. So this point is called the vertex, okay? In this case, it is a minimum. Our vertex is a minimum. It's that bottom point, all right? And it is actually an ordered pair. It's a point, you guys. It's an XY point. That's important. So that means we want to figure out what is this ordered pair? What is this point that represents our vertex? How do we find it? And there's a special formula that we're going to use to find that vertex, okay? So we need to find both the x coordinate of the vertex and the y coordinate of that vertex, right? We need to find the x and the y, all right? So here's how we're going to do it. The x coordinate of the vertex is equal to negative b over 2a. So again, knowing how to quickly find those A, B, and C coefficients is really, really important because we're now going to use them to find all these different pieces of our parabola. So to find the x coordinate of the vertex, we need to plug in whatever our B value is and whatever our A value is into this formula, negative B over 2A. That's going to give us just our x, okay, you guys? We also need a y. Right, we're looking for an ordered pair here. This is a point on the graph. We need an x and a y, right, to graph that point. So how do we find the y? Well, whatever value we get for x here, after we solve this equation, whatever value we get for x, we're going to plug it in to our function, all right? So if we got 2 for x, well, then we'd plug 2 in and to find our y. So this just reads that our y coordinate of our vertex is f of whatever our x coordinate was, okay? Our x coordinate is negative b over 2a, so whatever we get when we do that, we have to plug it into our function. That's all that says. And it's going to be a lot more clear in a minute. We're going to actually do an example. So let's look at this example that I have right here on the screen, okay? This function is y equals x squared minus 10x plus 19. Here it is, okay? The first thing I'm going to do And the first thing you should always do when you're dealing with a quadratic function and you're trying to graph it is you should write down your a, your b, and your c. Okay, so I'm going to look at my quadratic function here, x squared minus 10x plus 19, and I'm going to find my a, my b, and my c. I know my a is the coefficient that comes before my x squared term. It's that invisible 1, so my a equals 1. I know my b is the coefficient that comes in front of my x term, which is negative 10, so my b is negative 10. And I know my c is that number that just sort of hangs out at the end, that constant that hangs out at the end. It's technically in front of my x to the 0 term, okay, which is just 1. So here, that constant hanging out at the end is a positive 19. So my c equals a positive 19. Now I have my a, my b, and my c, and I can start using them to sort of figure out different pieces, right? So let's figure out the vertex. Well, I know that the x coordinate of the vertex is equal to negative b over 2a. Well, I said that my b was negative 10, right? So here I have a b. I'm going to plug in my negative 10 wherever I see a b. Okay, so the x coordinate of my vertex is negative b over 2a. So I have my little negative sign here, and then where my b was, I plugged in a negative 10. My 2 is going to stay, and now I need to plug in my a. Okay, my a here was 1, right? So I plugged in a 1 there. All right, 2 times 1 is just 2, which leaves me with 2 right there. Okay, that's my next step. Then I decided I just have to use some algebra, right, to solve from here. I was going to do negative 10 divided by 2, which gives me negative 5. I can't forget this negative sign that I had hanging out in front. Those two negative signs are going to cancel, and that leaves me with just 5, okay? So the x coordinate of my vertex is 5. I'm not done, though, because remember, the vertex is a point, which means I need an x-coordinate and a y-coordinate. I've found my x-coordinate, it's 5. I now need to find my y. What I mean by that, let me clear some of this up so it's not so messy. Okay, well, to find the y-coordinate of my vertex, I'm simply going to plug the x value that I just got into my function, right? Here's my function, x squared minus 10x plus 19. So wherever I see an x, I'm going to plug in the value 5, okay, which gives me 5 squared plus 10, or minus 10 times 5 plus 19, okay? I just simply took this 5 right here and I plugged it in everywhere I saw an x in my function, okay? So 5 squared is 25, 10 times 5 is 50, 19 is just going to stay 19, 25 minus 50 is negative 25. Negative 25 plus 19 is negative 6. So now, you guys, I actually have an x-coordinate and a y-coordinate, which means that I know the vertex. The vertex is going to be the point 5, negative 6, right? I plug in my 5 for my x-coordinate. I solved to find negative 6 for my y-coordinate. And if we look at this graph up here, you guys, let's look at my graph up here. Well, that looks pretty good, right? Let's go over 1, 2, 3, 4, 5, and down 1, 2, 3, 4, 5, 6. And yeah, that does bring us to this point right here. Okay, so I went over 5 and down 6, and there it is. All right. 5, negative 6. So that is how you find the vertex, okay? You're going to plug it in. You're going to plug in your a and b values. You don't really need c to find the vertex. To this lovely formula to find your x-coordinate, and then whatever you get for your x-coordinate, you plug into your function, right, to find your y. All right? So that's how you do it. So remember, it's important to understand that a vertex is a point, which means it needs an x-coordinate and a y-coordinate. And what point is it? Well, it's either the minimum if you have a parabola that's concave up, or if our parabola had been concave down, it would have been the maximum point. All right?